There we go. Okay. Okay, so yesterday where we stopped was, so we are in the middle of graphing things. Okay, so to graph any equation by hand, we just have to come up with about 3 different points. Okay, remember. Now, to obtain these 3 points, we just plug in some small whole numbers to x or y. Okay, so here, most people end up choosing like 0, 1, and 2, and so on, or even maybe -1 or -2. But that might change depending on what kind of equation you have. Okay, so for example, in this part A, you cannot choose any odd numbers for x, because if you do, you cannot get rid of this fraction. Okay, so you have to choose some even numbers. Of course, 0 is an even number as well. Okay. So you have to be a little bit careful choosing what kind of x values need to be chosen so that you get a legitimate y value. Okay. Now, 3x minus 2y is equal to 6. Okay, so that's part B. Okay, so we have to come up with this table thing. Okay, for x and y. So let's see. Okay, so here is the column of x and y. Okay, so I guess we can start with the easiest number, I guess, okay, which is a 0. Okay, so say x is equal to 0. Okay, so what does that mean? We just have -2y is equal to 6, right? So by dividing each side by -2, we end up with what? Y being equal to -3, right? Okay, make sense? Okay, so now notice that from yesterday's class, even before we graph, the graph of this equation will be what? Also a line, right? You see that? Because we can rewrite this into the so-called slope-intercept form, okay, right? Because, you know, we can isolate y by subtracting 3x and so on. So that will be a line, okay? And remember, any line has what? There are 2 special points, which are x and y intercepts. Remember that? Okay, so any line will have x-intercept and y-intercept. int means intercept, okay? So basically, what does this mean? This is a point 0, -3. And if you think about it, this is on the y-axis, right? So that is the y-intercept, okay? So in particular, how do you obtain the x-intercept? So you have to plug in 0 into what? X or y? Y, right? Okay, that's how you get the x-intercept, okay? So when y is equal to 0, what do you notice? That is gone, right? Okay, that is gone. So you just have what? 3x is equal to 6, right? Okay, so x is equal to what? 2, right? Okay, so we have these 2 points. Okay, so we just need one more, maybe. So what do you notice here? So we have used 0, we have used 2. So maybe you can try 1 and see what happens. But when x is 1, what do you notice? You have 3 minus 2y is equal to 6. And you can quite easily verify this. But when you solve for y, what do you get? Fraction or whole number? Fraction, right? Do you see that? Because you subtract 3, so you get like what? -2y is equal to 3, right? So it's not a whole number, right? Okay, so 1 doesn't work. Okay, so maybe we can try what? Like maybe 4? Okay, so hopefully you can deduce that any odd number for x will lead into non-whole number or fraction. Okay, so maybe you can try the next even number, which is 4. Okay, so what do you get? 12 minus 2y is equal to 6, right? So by subtracting 12, what do you get? So that means -2y is equal to what? -6, right? Okay, so by dividing by -2, y is equal to +3, right? Okay, so to clean things up, what are the three ordered pairs or 3 points that we get? 0, -3, 2, 0, and 4, 3, right? Okay, so now we can graph things. So 0, -3, so that's below x-axis right here. So 0, -3. And then 2, 0 is here. And then 4, 3 will be in the first quadrant, maybe somewhere here, okay? So again, we knew how the graph will look like, but this time, how does the line look like compared to the previous part? So this one was the decreasing line, right? Okay, but what about here? This is an increasing line, and of course, remember, you have to extend your line beyond these 2 points, right? Because the line just keeps going, like to the upper left or the upper right and bottom left, okay? So that is the graph. Okay? So now, that is B. And then C. Okay, so C, you have y equals square root of x minus 3. Okay? So now, here, we have a square root. Okay, so we have to be, again, a little bit careful. Okay, so now here, we will not end up with fractions for, choosing the right x values, but what we may end up with is what? We may end up with the square root that's being survived. You see why? Like, for example, what if you chose x being equal to 2? Then you have square root of 2 and then minus 3, right? Now, even though we don't see a fraction, what's the issue here? That's not a whole number, right? Okay, so it's just square root of 2 minus 3, and that's just like irrational number, right? Okay, so in particular, like 2 doesn't work. So what can you deduce? You have to choose what?
Perfect square.
The perfect squares, right? Yeah. Okay, so what are some examples of perfect squares?
4.
Okay, 4. So when x is 4, yeah, actually, like let's evaluate y later. So what are some other perfect squares that you can think of?
9.
And
16.
16. Okay. So now, when x is 4, y is square root of 4 minus 3, which means 2 minus 3, so that's -1, right? Okay. And when x is 9, we have square root of 9 minus 3. And that's 3 minus 3, which is equal to 0. And when x is 16, we have square root of 16 minus 3. So that's 4 minus 3, so that's 1, right? Okay. So we have what? 4 comma -1, 9 comma 0, and 16 comma 1. Okay. So if we sketch the graph, how does it look like? So 4, -1. So that's, okay, so maybe 1, 2, 3, 4, and then -1. So somewhere here. And then 9, 0. Okay, so that's like way on this side. Okay, like 9, 0. So that's way on this side. So maybe somewhere here. This is not in scale. And then 16 comma 1. Okay, so 16 comma 1 is, okay, so like maybe somewhere here. Okay, like something like this. Now, from yesterday's class, we have seen the rough graph of the square root of x. Let me see if I can find it. I think it's somewhere here. Oh, nope, that's not. Maybe it's on the previous page. Let's see. Okay, right here. So remember, the graph of the square root is not a line, right? It's just half curve, like uphill curve, right? Okay. So since the only difference between this equation and the square root of x is what? The -3 in the back, right? So what does that mean? It has to have this like uphill curve, right? Okay, but it will be slightly different, like in terms of the position, right? So based on how these 3 points are lined up, can you see like the slight uphill? Okay, like it looks like, you know, like they're forming a line, but it's not, right? Okay, but at least we see this slight uphill, like something like this, right? Oops, something like this. Okay, now the point is this so-called anchor point of the square root of x was what? At the origin, right? 0, 0. Okay, now where will the anchor point be for this square root of x minus 3? Okay, so it looks like the graph will extend something like this, right? Looks like it. Okay, so now the thing is, where is this point? Where is this point?
-3.
-3, yes. Do you see why? Now, can x be equal to 0? And let's see. So square root of 0 minus 3, right? And what is that? 0 minus 3, so that's equal to -3, right? So what does that mean? This point is equal to -3, and that is the anchor point of this graph. Okay, and then remember, the graph does not extend beyond this point, right? Like it doesn't go this way. However, does it extend this way along the positive x direction? And the answer is yes. Okay, so the graph starts right here, and then it forms this slight uphill, and then it just keeps slowly increasing. Okay, so that is the graph of square root of x minus 3. Can I go to the next page? Yeah. Okay, so that's C and then D. Okay, so now y equals, okay, that bar thing. Okay, now what does that bar thing mean? The bar thing is what? Absolute value, right? Okay, now yesterday we saw absolute value of x graph, right? Not x plus 1, right? And do you remember how the graph was like? Let's see, the V, remember that? Okay, so now what should you notice? So for absolute value of x plus 1, it also has to have the V shape, right? But of course, the position will be slightly different, right? Okay, but let's see if we can come up with a few points, okay? So let's see, let's start off with maybe the easiest point, maybe 0, right? Okay, now, in that case, what's the value of y? It's the absolute value of 1, right? Okay, absolute value of 1. And what is that? Just 1, right? Okay, and now, what can we choose? What else can we choose?
One,
And
2,
okay, so 1 and 2. So when x is 1, we have absolute value of 2, right? And what is that? It's just 2, right? And when x is 2, we have absolute value of 3, which is equal to 3, right? Okay, so we have these 3 points. So now, how does the graph look like? So let's see. So 0, 1. Okay, so 0, 1 is somewhere here. And then 1, 2. So that will be somewhere here. And then 2, 3 is right here. Okay, so by looking at how these 3 points are lined up, we definitely see what? A line, right? Okay, it looks like this. Okay, now what's the problem? We don't see the V, right? Okay, we just see a line, but we don't see the V. Okay, so how could we see the V? Okay, so now, first of all, the line after this 2, 3, it has to extend, right? Okay, so that is fairly easy to deduce. Now, where is the other branch in V? So it looks like the graph has to go past this point, right? 0, 1. Okay, it looks like it, right? Now, the point is, where does the graph make a turn? Okay, so to see that, let's plug in a negative number, say -1. Okay, now when x is -1, what do you have? It's absolute value of 0, right? And what is that equal to? 0, right? Okay, so what does that mean? It passes -1, 0. Okay, and now let's try one more. So when x is -2, what do you have? Absolute value of -1, and that's equal to +1. So what does that mean? When x is -2, it passes -2, 1, which is right here. Okay, so at this point, what do you notice? The line does not go past 0 or -1, 0 like this, but rather it has to make a turn, right? Like this. Okay, so here comes the V shape. Okay, so again, compared to what we saw in absolute value of x graph, whose this sharp point was again at the origin, where is this sharp point? -1, 0. Okay, so it's shifted to the left by a unit. Okay, but still we maintain the V shape. Okay, so now the last one, -x cubed. -x cubed. Okay, so now yesterday, remember, we saw positive x cubed. This one, remember that? Okay, so it has this S shape or the snake shape or whatever, right? So now, what's the difference here? We have -x cubed. Okay, so first of all, what should we expect? The same S shape, right? Well, of course, the shape might be different, but it has to have some kind of S shape. Okay, so let's see. Let's choose some X values. So let's see, what can we choose? Maybe -1 and 0, 1, and 2, maybe. Okay, so now when x is -1, what do we have? Negative of -1 cubed, right? Okay, and now what does this mean? So we do -1 cubed first, right? And what is -1 cubed?
1.
-1 cubed, -1 cubed. So what is that? -1, -1, -1, right? And what is that? -1, right? Okay, and now there's extra negative sign in front. So in total, this implies what? +1, right? Okay, and now when x is 0, we just have 0, right? Okay, so that's very easy. And now when x is 1, we have -1 cubed. Okay, so what does that mean? 1 cubed is 1. And with the negative sign, we have -1, right? And when x is 2, we have -2 cubed. Okay, and the 2 cubed is what? Don't say 6. Okay, it's not 6, right? Okay, it's what?
8.
8, right? Yeah. Okay, so we have -8, right? Okay, so how does the graph look like? So -1, 1. So that's somewhere here. 0, 0. 1, -1. somewhere here. And then 2, -8. Okay, so that will be way down here, right? Okay, so now, can you see the shape of the graph? Okay, so again, remember we have to have some kind of S shape, but what do you notice here? What happens to the regular S shape? It looks like it's flipped, right? Okay, so remember this was the regular S shape for x cubed, right? But this is negative x cubed. So what does that mean? How do you get, or how do you compare this S with the original S? It's the reflection, right? Do you see that? Now, reflection over what? The y-axis, right? Okay, like you have to flip it like this, and then you get this backward S shape, right? Okay, so it's the reflection. Now, when we go to section 2.7, we will study all of these, like reflection and then shifting a bit closely, but at this point, you just have to know how to sketch the graph, okay? Any questions over these graphing problems? Okay, so this quickly wraps up 2.1. And now let's go back to chapter 1, and then we will finish things there, okay? So now 1.5. Okay, so now 1.5 is about, I guess, one of your least favorite topics, word problems. So unfortunately, so many people hate word problems simply because, I don't know, like people feel comfortable with reading English books like novels, but somehow when it deals with math, people just absolutely hate it. And I just wonder, well, if you're okay with reading novels, then how can you be not okay with solving word problems in math? But I don't know, like that just scares people. However, in word problems, one thing to make sure is not every x values will work, depending on the context of each problem, okay? So you have to be a little bit careful. Now, since most people usually struggle with these word problems, I only prepared, I think, like 5 problems only, yeah. Okay, so it's not that many, but of course that's more than enough to scare people. So here is the first category, geometry. Okay, so apparently some people in the past said they loved their geometry class in high school, whereas some said they absolutely hated geometry class. Now, no matter what, at least you have heard about this Pythagorean theorem, right? It's, you have to be a little bit careful pronouncing his name, but it's invented by Pythagoras, right? Or Pythagoras, whatever, okay? Now, do you remember its statement? So it deals with what? What kind of geometric figure? Right triangle. Remember that? Okay, and there are labels A, B, and C, right? Now, although there are some discrepancies, most people choose to label like this. Okay, so that's the kind of nearly standard representation. Now, what are the names of the A and B? Like, how do we call them, A and B, other than sides? Other than side, how do we call them, A and B?
Are they called legs?
The legs, yes. Remember that? The legs. Now, what's the name of this C? How do we call it?
Hypotenuse.
Hypotenuse, yes. Okay. Now, what is the statement in terms of A, B, and C? Like, what's the formula?
A squared plus B squared equals C squared.
Remember that? Yeah. Okay. So we will use this fact on the next problem. And remember, and hopefully you have seen this tip before, always drawing a picture is a good idea in geometry problem, right? Because that will help visualize what's going on in each problem. Okay. So number one, there was a settler who came to California. Oh, we have a baby. In 1860, and he or she had a land shaped as a right triangle, okay? Now, the hypotenuse of a right triangle is 8 inches longer than the shorter leg, and the longer leg is 4 inches shorter than the hypotenuse. Find the dimensions of each side. Now, apparently some people have excellent guessing skills for this kind of problem, which I do not possess. So I sometimes tend to be kind of jealous of people's excellent guessing skills. So there we go. That's why I said this. Do not guess, okay? Use math. Although some people say, well, guessing is also a math. No, it's not, okay? So, no, it's not. You have to use some kind of equation type thing, okay? So, here is the right triangle. Okay, so let's start off by drawing a right triangle. Okay, like this. Okay, now, hopefully you have seen this scheme before. There are 3 unknowns in this problem. Do you see them? What are the 3 unknowns? The 2 legs and then the hypotenuse, right? Yeah, so there are 3 unknowns. However, only one of them can be set it as x, okay? Because we cannot set x, y, and z or a, b, and c like this because then there are 3 unknowns, right? So only one of them can be x. Now, based on how the statement in this problem is given, what seems to be the best to be set as x?
A.
Say that again.
Is it A?
A, yes, the shorter leg. Do you see why? Okay, so now let's see why. The hypotenuse is 8 inches longer than the shorter leg. Okay, so we know a little bit more about the hypotenuse, right? And the longer leg is 4 inches shorter than the hypotenuse. Okay, so we know a little bit more about the longer leg as well. But what do we know about the shorter leg? We know nothing, right? Okay, so that's why x needs to be the shorter leg, yes. Okay, so that is x. Okay, so now what do we do next? Let's express the longer leg, which is b, and then the hypotenuse, which is c, in terms of x. Okay, so what can we do? So what's the expression for the hypotenuse in terms of x?
X plus 8.
X plus 8. Do you see why? 8 inches longer, right? Wait, here. So what does that mean? X plus 8, right? Yes. Okay, x plus 8. And now, what's the expression for the longer leg in terms of x?
X minus 4.
X plus 4. Yes. Do you see why? Okay. Now, the longer leg is 4 inches shorter than the hypotenuse, right? So what does that mean? X plus 8 and then minus 4, right? Okay, in short, this is equal to what? X plus 4, right? Yes. Okay, so we have x plus 8 and then x plus 4 and then x, right? Okay, so that is the first step. And now, what is step number 2? Let's set up the equation. And now, what's the relationship between x plus 4, and x plus 8? It's this one, right? a squared plus b squared equals c squared. And be careful, what needs to be squared and what is on the right-hand side and left-hand side. So that's like a, and that's like b, and that's like c, right? So what does that mean? It's x squared plus x plus 4 quantity square is equal to x plus 8 quantity square, right? Okay. And now we just have to solve this. Now to solve, what do we do first?
Do we FOIL the 2 to each?
Right? FOIL x plus 4 squared and x plus 8 squared. Yes. Okay. So that must be the first step. Okay. So what do we get? X squared stays the same, and then we have x squared, another one. And now here, let me skip a step. We have plus 4x, right? So what does that mean? Plus 8x, and then plus 16, right? And then the other side, x squared plus 8x, so that means plus 16x, right? And then 8 squared, so that's 64, right? Okay. Again, please do not say x squared plus 16 for this one and x squared plus 64 for this one. Okay, you must FOIL it. Okay, be careful. Okay, and now what do? We can combine like terms, which is this one, right? Okay, so we have 2x squared plus 8x plus 16 is equal to x squared plus 16x plus 64. You see that? Okay, and now what do we do? How do we solve this?
Get x by itself on one side of the equation, move everything else.
Right, so what do we move? Move these three things to the right or these three things to the left? What is better?
Keep x on the left.
Right, so subtract x squared, 16x, and 64. In other words, move all of these into the left. Do you see why? If we go the other way, what's the problem? The sign of x squared becomes what? It's negative x squared, right? Okay, so to maintain the positive coefficient for x squared, we subtract x squared, 16x, and 64 to each side. Okay, so in other words, do that. So what do we get once you simplify? So we get x squared, and then that's minus 8x, and then that's minus what, 48 equals 0. Okay, and now how can we solve this? Now this is a quadratic equation, right? Which means we have 4 ways to solve, factoring, completing the squares, square root property, and quadratic formula. Now, although the quadratic formula works all the time, that is not the fastest method. In fact, the fastest method is, if you can see it, the factoring. Okay, so you always have to wonder whether certain things can be factored. So can we factor this?
Yes.
Yes, we can. Now, what are the two numbers?
12 and 4.
Okay, 12 and 4. Now, is there any negative sign?
Yeah. When I factored it, I got x minus 12 and then x plus 4.
Right, negative 12 and 4, right? Yes. Okay,
Yeah.
so x minus 12 and x plus 4. Okay, so what does this imply? This implies x is equal to 12 and negative 4, right? By setting each factor equal to 0, right? Okay, so now, earlier when we got the values for x, that was it. Now, what about here? Are we done? Is the answer 12 and negative 4? And to answer that question, let's see where we have started. What was x? So what does x mean basically? X was what? The shorter leg, right? Okay, now what do you know about any length? Can it be negative? No. So what does that mean? Which one doesn't work? This one doesn't work, right? Okay, again, the reason is any length cannot be negative. Okay, so that's why negative 4 is out. Okay, so is the answer equal to 12? Are we done at this point? And the answer is unfortunately no. Unfortunately no. And now, why? Are we trying to find the value of x or are we trying to find something else? The problem says find the dimensions of each side. So what does that mean? 12 is not the answer, right? I mean, it's part of the answer. So what is the real answer? 12, which is what? The shorter leg, right? And what are the other two dimensions? 16 and 20, right? 12 plus 8. Okay, so that is the answer. Okay, so there are lots of significant things here. Not only you have to be able to set up the right equation, but also after you solve for x, one of them is out. And then for the survived x, you have to plug that value back into the picture and then get this answer. Okay, be careful. Yeah, that's why the word problems are ugly. Okay, so now that was number 1. Can I go to the next page? Okay, so now if you thought this number 1 was ugly, now look at this problem. So it looks like it's fairly easy problem, but you will see that this problem is more weird than number 1. Now, find the length of the side of a square given that the area minus the length is 650. Okay, so now what's the object here? It's not a right triangle, right? It's the square. Okay, and hopefully you already know how the square looks like. Okay, yeah, how does the square look like? Something like that, right? Okay, 4 equal sides, right? Yeah, okay. Now here, what is the unknown? What are we trying to find?
The length of the sides.
Right? Which is what? X, right? Which means they're all equal, okay? So, length of the side is X. Now, what do we know about this square? The area. Now, how do you find the area of the square?
You multiply the two sides.
Right? Which is what? X times x or x squared, right? Okay. So it's x squared. And then it says minus, so that's minus. The length of the side, what is that? It's just x, right? And is equal to 650. Oh, okay. So that's the equation, which is fairly easy. Now, how do we solve this? So this is again quadratic equation, right? Okay. So what do we do? Subtract 650. So what do we get? X squared minus x minus 650 is equal to 0, right? You see that? Okay. And now again, the obvious step, let's see if we can factor this. Okay, so now here comes the challenge and the main body of this problem. It's really tough to see whether we can factor this. Now, here I put factor with a question mark, but let me add this exclamation mark because we can factor, okay, can, not cannot. We can factor this. And now, here, what do we have to do? So here what we do is, what? The sum of the two numbers is -1, and then the product is what? -650, right? And we have to find the two numbers that satisfy both conditions at the same time. Now, can anybody see the two numbers that satisfy these two conditions? If you do, I'll be amazed. Can you see it right away? No, right? It's really challenging. Okay, so let's take some slick approach. So here is my tip. Okay, so now let's focus on this number 650. Okay, now think of two perfect squares such that 650 lies in between. Okay, in other words, we have something and then 650 in the middle and then something else here. Okay, but these two numbers have to be the perfect squares. Now, can you come up with which perfect square goes into this spot? That would be a little bit easier. Okay, so don't worry about this blank, but come up with the perfect square that's less than 650, but it's as close as possible to 650.
640?
That's a little bit big. And that's not a perfect square.
Okay.
Yeah, so it's somewhere in the 600 range, but it's not 640. Okay, so here's my hint. 20 times 20. What is 20 times 20? Times 20? That's what, 400, right? Okay, so our number has to be greater than 400. Okay, so to come up with our desired number, it has to be greater than 20, but it has to be less than 30, right? Because when we multiply 30 by itself, we get 900. Okay, So it's somewhere between 20 and 30, and you have to multiply it by itself to come up with this perfect square. And if you do a little bit of math, like the average of 900 and 400 is about 650. So it has to be somewhere in the middle of 20 and 30.
25.
25, yes. Okay, now when you multiply 25 by itself, what do you get? 625. Do you see that? Okay, so 625 goes here, which is 25 squared. Okay, now it doesn't matter which number goes into here, but now you take the square root on everywhere. Okay, so what does that mean? Square root of 625, and then square root of 650, and then square root of whatever the number is. Okay, which doesn't matter. Now, what is the square root of 625? 25, right? Because 25, yeah, 25 squared is 625, right? So its square root has to be 25. And that we don't know. Now, what is the square root of this number?
26.
26, yes. Do you see why? Because we don't know what this perfect square is, but it has to be the next largest number after 25, right? So it has to be 26. Okay, now we have all the ingredients. Can you produce -1 from these two numbers? How can you come up with -1 from 25 and 26?
Positive 25 and negative 26.
Positive 25 and negative 26. Yes, do you see that? Okay, so going back to here, the two numbers are -26 and 25. Okay, now, does this trick always work? No. Okay, it was designed like this. Okay, so whenever the number is really big, like even 4-digit number or even 3-digit number, then and when the sum is 1 or -1, this is the way to proceed. Okay, so now what do you do? Now we can factor, right? So what do you get? X minus 26 times x plus 25 equal to 0. So what does that mean? X is equal to 26 and -25. Now, do both numbers work or only one of them works?
Only one.
Only one. Which one works?
26.
26, right? Yeah, that doesn't work, right? Because x was the length of the side, okay? So what do you notice? This one looks a bit easier than number one, but number one, I feel like it's a lot more straightforward to solve. This one is not so easy, okay? But still part of geometry, okay? Now, let's look at the last problem in the geometry part. Okay, so this one looks challenging, and it will be the case, although I think it's a little bit easier than number two. But let's see what's going on. The length of a rectangular cardboard is 10 feet more than its width. Okay, so now let's pause here. Let's pause here. Okay, so now what's going on? So we start with the rectangular cardboard, which looks like this, right? Okay, now any rectangle has length and width. What is the length? Which part is the length?
The longer side?
right? So that's the length. And then that's the width, right? Okay. So now, squares with the side 3 feet long are cut from the 4 corners. Okay, so now let's pause here once again. So what does that mean? On this rectangle, these squares are cut out, right? Okay, so that has been chopped off, these 4. Okay, and it has the side length being equal to 3. So what does that mean? That's 3, that's 3, 3, 3, 3, 3, 3, 3, right? Okay, and these 4 squares are cut off. And the flaps are folded upward to form an open box. Okay, so now pause here. So what does that mean? Here are the folding lines, right? Okay, and what do you have to do? These 2 has to go up like this, and these 2 has to go like this, right? Okay, so you have something like this, right? Okay, and this box doesn't have a lid, right? Like it looks like this. Okay, so there's no top part, right? Okay, now if the volume of the box is 432, what were the original dimensions of the cardboard? Okay, so how many unknowns do we have here? Original dimensions of the cardboard, which was what? The rectangle, right? Okay, so what does that mean? How many unknowns do we have in this rectangle? 2, length and width, right? You see that? Okay, but like we did before, only one of them can be set as x. Now, based on how the problem is written, we have to set x to be the width or the length. Which one is better?
The width.
The width, yes. Do you see why? It says the length is 10 feet more than the width. Okay, so width is x. Okay, so what does that mean? So width is x. So that means the length is what? X plus 10, right? Okay, so we have x plus 10 for this length. Okay, so now that's step number 1. Step number 2. Step number 2. Let's go to this box here. It says the volume is 432, but in general, how do you find the volume of any rectangular box? What's the formula? Like, how do you find the volume of this like rectangular box like this?
Is it length times width times height?
Length times width times height, yes. Okay, so here is the length, here is the width, and here is the height, right? Okay. Okay, so now here's my trap question. Is the length equal to x plus 10? Is L equal to x plus 10, basically? No. And why not? X plus 10 was the length of the original rectangle, right? But do you form this open box from this original length or like original rectangle? No, you cut out some pieces, right? Okay, so what is the step number 3? Express L, W, and H in terms of X. Okay, because L is not X plus 10 and W is not X. Okay, X was the width of the rectangle, not the box, right? Okay, so let's start off with the length part. Okay, so L. So in other words, what is the expression of L in terms of X? So going back to this picture, where is L? This one is L. Do you see that? Okay, so now, how do you get L from the original length, X plus 10?
X plus 10 minus 6.
X plus 10 minus 6, yes. Do you see why? So it's X plus 10, which is this one, and then you cut out 3, you cut out another one, right? So what does that mean? X plus 10 minus 3 minus 3, right? And what is that? X plus 4, right? Okay, so X plus 4 is the length of the box. And now, what's the expression of W in terms of X?
X minus 6.
X minus 6. Do you see why? So that's the W. And how do you get W? You cut out 3 and 3 from X, right? So it's X minus 3, so that's X minus 6. And now, what's the expression for the height?
Would it just be 3?
Do you see that? Okay, so how do you form the height? These two edges will be joined together, right? And that will form the height. Okay, so height is equal to 3, yes. Okay, so now next step. What do we have to do? To get the volume, we need to multiply L, W, and H. Okay, so what does that mean? X plus 4 times X minus 6, and then times 3, and that's equal to what? The volume is 432, right? Okay, so that's the equation. Now, our goal is to solve this. Okay, now here the number, which is 432, is a bit large. Can anybody see the way to reduce this number, 432? By doing something to both sides of the equation, we can reduce that 432.
You divide it by 3.
Divide by 3, yes. Okay. Instead of foiling this everything and then multiplying by 3, we can divide by 3. And what happens? When you divide everything by 3, these 2 is canceled. Okay, so it's X plus 4 times X minus 6. And then 432 over 3. What's that equal to? 144? 144? Okay. I mean, still we have 3-digit number, but it's way better than 432. Okay. So now, how do we solve this? Now, have we seen this kind of equation before? So what do we do here? There is only one way.
Foil?
Foil and one more. Okay, foil and do one more.
Oh, for X.
Right, so subtract 144. Okay, so we FOIL and subtract 144. So what do you get? So now let's go to this side. Okay, so what we do is x squared, and now minus 6x plus 4x, so that becomes minus 2x, right? And then minus 24 minus 144 is equal to 0, okay? So by combining like terms, we have x squared minus 2x minus, that's what, 168 equals 0. Okay, so now let's see if we can factor this. Okay, so what do we have to do? The sum is negative 12 and the product is negative 168, right? Now, here, I'm sorry, oh, negative 2. Negative 2.
Okay.
Yeah, sorry. So now, here, again, we are dealing with 3-digit number, but it's not too terrible finding the two numbers compared to the previous problem. Can you come up with two numbers that satisfy two conditions at the same time?
14 and 12.
14 and 12, yes. Now, where is the negative sign?
It'd be x minus 14, so it's in, it would, but if you're gonna solve it, it'd be x, or it'd be negative 12.
Right, yeah, do you see that? Okay, so it's negative 14 and 12. So we have x minus 14 and x plus 12 equals 0. So x is equal to 14 and negative 12, yes. Now, are we done or one of them doesn't work?
One of them doesn't work.
Which one doesn't work?
Negative 12.
Negative 12 doesn't work. Why? Because x was the width, right? Okay, so 14 would be the x. Now, are we done at this point?
No.
No. What do we have to do? So find the original dimensions was the original problem. So 14 is the width. So what's the length?
24.
24, right? X plus 10. Okay, so here the answer is width 14, length 24. Okay, so that is the answer. Okay, so any questions on these geometry problems? Yeah, it's challenging. Any word problems are challenging. Okay, so now let me go to the next page. So the second type, projectile problem. Okay, now maybe some of you have taken physics class in your high school or in the past. Am I correct? Yeah? Did you like physics? Yeah, most people say they like hate with passion for physics, but here is a basic physics problem. So suppose you throw a pickle vertically upward from ground with the initial speed of 60 feet per second. Actually, it has to be 80. There's a typo here. Its height, s in feet, above the ground after t seconds since takeoff is given by negative 16t squared plus 80t. Okay. When will the pickle reach 64 feet above the ground? Okay, so now what's going on here? What's the situation? So here's a pickle. Okay, looks like a stone. So here's the ground, okay, and it's launched upward, right? Now, you know what will happen to this pickle, okay? Because of what? So-called famous gravity, okay, gravity, this pickle will go like this, and then what happens? It will come back to the ground, right? Okay, it doesn't go all the way to the universe, right? It's not like SpaceX. For those who have seen the launch, when was it, last week? Anyways, so that's the situation. And now, when will the pickle reach 64 feet above the ground? So here, in this problem, there are two unknowns, S and T. Okay, now what does 64 represent, S or T?
S.
S, yes. Do you see why? 64 is the height, right? Okay, and T is the time, right? Yeah. So that is the height, and when means T, right? Okay, so here, what's the situation? We plug in S equals 64. So we have what? Negative 16t squared plus 80t is equal to 64, right? Okay, and I guess the goal is obvious. Solve for t, right? Okay, now, how do we solve for t, for this problem?
$64 over and factor it.
Okay, so subtract 64. So we have negative 16t squared plus 80t minus 64 equals 0, and then factor. Okay, now, how do we factor this? So here the numbers are fairly big. Can we pull out some number? What can we pull out?
4.
Okay, can you pull out more?
8.
Can you pull out more?
16.
Can you pull out yet once more? There is only one thing that can be pulled out. So there's no bigger number than 16, but you can also pull out something else.
Negative.
Negative.
The negative sign, yes. Okay, so the GCF is negative 16. Okay, so you have negative 16 times what? T squared, and then you have plus 80t, but when you pull out the negative 16, you have minus 5t, right? Okay, and then from negative 64, when you pull out negative 16, it's plus 4, right? Equals 0. Okay, and now, can you factor even further, especially here? What are the two numbers?
Four and 1.
Okay, 4 and 1, does it have negative sign?
Yes.
Where?
Inside it'd be t minus 4 and then t minus 1.
Right, to both, right? Yes. Okay. So now from here, can you see the values of t? So t is equal to what?
One and 4.
1 and 4. Okay, from here. Now, do we also set that equal to 0?
Say that again.
Do we also set negative 16 equal to 0?
Oh,
No. And what's the reason? This is false. Okay, so many people just said negative 16 equal to 0, but remember, you cannot set a pure number equal to 0 because it will be just false, right? Okay, so that's just false, so it's only 1 and 4. Now, here is another trick question. Do we cross out one of the t values? Or do we keep both? Or do we throw out both?
Keep
it's
both.
both.
Keep both, yes, this time.
Because it's
Why?
going up and when you're coming back down, right?
Did everybody hear that? Okay, so where is 64? Somewhere here, right? Okay, so what does that mean? It will hit 64 once, so that means 1 second since takeoff. And then when it comes back to the ground, it hits once again. Okay, so this time, both numbers are okay. Okay, so that's why earlier I said you have to be careful, because sometimes you may have to cross out one number, but some other times you may have to keep both. Now, part B, how long will it take for the pickle to return to the ground? And something bad happens, okay? Right, yeah. So here, what are we trying to solve for? S or T?
0.
Okay, yeah. So we are trying to solve for T, right? And now plug in which value for X? S, 0. Does everyone see that? And now Y, what's the magic word? Ground. Okay, and it says how long, so it means find the time, right? Yes, okay. So because of the word ground, which means the 0 height, we plug in S equals 0. Okay, so we have negative 16t squared plus 80t is equal to 0. Okay, and now let's see if we can factor this. And can you take out something?
Can we take out the 16 again?
Okay, now can you take out some more?
The negative?
And
T.
T as well, yes. Okay, so the GCF is negative 16t. Okay, so we have negative 16t, and then what? T, and then minus 5, right? Equals 0. Okay, now, can you see the values of t? So I guess it's fairly obvious to set t minus 5 equals 0, right? Do we set this thing equals 0?
False.
Yes, we do, finally. Why? Because of what? That. Okay. Now, earlier I said never set pure number equal to 0, but that's not a pure number, right? It's just a variable expression, okay? So we do set negative 16t equals 0. So what do you get? T equals 5, or t is equal to what?
16.
Be careful. It's not negative 16 plus t, it's negative 16t equals 0. So what do? Divide by negative 16, right? And what is 0 over negative 16?
0.
0, yes. So 5 and 0. Now, do we keep both or cross out one of them or cross out both?
Cross out 0.
Cross out 0, yes. Why? Because what does 0 second mean? The pickle
Hasn't left the ground yet.
Right, has not left the ground. Yes, it's there. Okay, the pickle has to be launched and then it will return to the ground. So that's why 0 doesn't work. Okay. Okay. So any questions on this projectile problem? Okay, now we're almost there. So just one problem remains. The third type, consecutive integers. Okay, so hopefully you have heard these 3 cases before. There are 3 cases: consecutive integers, consecutive even numbers, consecutive odd numbers. Okay, so now let's look at the problem or the case number 1. How do you get 2 from 1? Don't say times 2. So don't use multiplication. How do you get 2 from 1? Yeah, add 1, right? How do you get 3 from 1?
Add 2.
Yeah. And then add 3 to get 4, right? So now, let's say you start from x. What is the next integer after x?
X plus 1.
X plus 1, yes. And then x plus 2 and so on, right? Okay. And now, let's restrict on the even number case. How do you get 4 from 2?
To add 2.
Add 2, yes. 6 from 2, add 4, and so on, add 6, okay? So if x is an even number, what is the next even number after x?
X plus 2.
And then,
X plus 4.
right, and so on, right? Now, odd numbers, same thing. How do you get 3 from 1?
Add 2.
Right? And then add 4, and then add 6, and so on, right? So if x is an odd number, what is the next odd number?
X plus 2.
X plus 2, and x plus 4, and so on, okay? So here is kind of a tricky thing here. To get the consecutive odd numbers, it seems like we have to add x plus, or like we have to add 1 and 3 and 5 and so on to x. But no, we keep adding even numbers to maintain the oddness, okay? Now, why are we studying these 3 cases? Because the problem on the next page, can I go to the next page? Okay, so the difference of the squares of 2 positive consecutive odd integers is 32. Find the integers. Okay, so let's see, the difference of the squares of 2 positive consecutive odd integers. Okay, so now what does that mean? We have to look at which case. That, right? Okay, now how many consecutive odd integers are we considering? 2, right? Yeah, so what does that mean? These 2, right? Okay, so x and x plus 2 will be the consecutive odd integers. Okay, so x and x plus 2 are the consecutive odd integers that we consider. Okay, so now what does it say? Difference of the squares. Now what does that mean? What do we do first? Difference first or square first? What do we do first? The difference or squares? The squares. Do you see that? Okay. So the difference of the squares. So what does that mean? We have to do the square part first, right? Okay. So we have to do the squares. So x squared and x plus 2 squared. And now the difference, which means what? Subtraction, right? Okay. Now for subtraction, we can go one of these 2 ways. This one or the other way. Okay. Now, which one is it? So don't say it doesn't matter. It does matter. Okay. Which difference do we take? This one or this one?
Option 2, because otherwise you'd have to have a negative answer.
Does everyone see that? Okay. So it's not this one, but this one. Why? Because it says the difference is 32, which is what? Positive, right? Okay. And between x and x plus 2, which one is bigger? This one is bigger, right? Okay. So what does that mean? X plus 2 squared is also bigger than x squared, right? So if we do this, we end up with a negative number at the end, right? Okay, so it's this one. Okay, so what do we have? X plus 2 squared minus x squared is equal to 32. Okay, so now, how do we solve this? What do we first do? There's only one way.
Subtract 32.
Okay, yes, subtract 32 and then
FOIL.
FOIL, yes. Okay, so FOIL this and minus 32. Okay, so what do you get? X squared plus 4x plus 4 minus x squared minus 32 equals 0, right? Okay, so now it seems like we have the quadratic equation, but what do you notice here? The x squares cancel. Do you see that? Okay, so we have 4x minus 32 is equal to 0. And then what do you do?
Do you add 32 and then divide by 4?
Okay, so add 32, divide by 4, so x is equal to 8. Okay. Oh, wait, are we missing something? No, that's incorrect. Now,
What happened to this plus 4?
yeah. So that was my mistake. Sorry about that. So
Okay.
here we have
Oh,
28.
yeah.
Yeah, so there we go. Yeah, that looks better because we started off with odd integers, so I was thinking a little bit weird. So x is equal to 7. That looks a whole lot better. Okay, so x is equal to 7. Are we done? No, what's the answer? 7 and
9.
9, yes. Do you see why? 7 was x, the next odd integer, 9. Okay, so 7 and 9 is the answer. Okay? Okay, so that is it for 1.5. And now, let's go to 1.6. Okay, so 1.6. So the last two sections in chapter 1, 1.6 and 1.7 are the most challenging ones, unfortunately. So 1.6 has 6 types of equations. Now, I don't know why the author of the book has designed this section like this, because apparently there are lots of things to remember, but it is what it is. I didn't design the book. So, number 1, the first type, rational equation. Okay, so now, I hope you have heard the word rational before. The word rational means fractional. Okay, so fractional equation. Now, whenever people hear about the fractional equation, they kind of think of like this. Okay, that's not a fractional equation, unfortunately. That's just pure linear equation. But fractional equation means, not that, x appears in the denominators. Okay, so now, before we go any further, let's look at this next remark. Any fraction can go illegal. Okay, so illegal means like wrong, and it's not good, basically. How? There is one case that any fraction can go wrong. What is that case? It deals with the special number in specific location of the fraction.
Is it a 0 in the denominator?
0 on the denominator. And why? If 0 is on the denominator, what happens to the fraction?
It's just 0.
Uh-uh.
Oh.
0 is okay. But
Impossible.
0 at the bottom means what?
Taking something and putting it into a group of 0, which is impossible.
Right? Undefined. Yes. Okay. Undefined does not mean it's equal to a 0. It's just there's no value. Okay. So, in other words, what does that mean? Bottom can't be a 0. Okay. And that's what these bad values mean. Okay. Now, that's just my own notation, the bad values. But the bad values mean the x values that make denominators equal to 0. Okay, and hopefully you can see why I call them bad values. It's bad because they will make any fractions undefined. And undefined is illegal, okay? So it's the bad values. So now, conversely, how do you find the bad values? Well, you have to assume the worst possible scenario, which is what? Assume the bottom was 0 and find out what kind of x values gives us those bad values, okay? So to find bad values, to find them, set denominators equal to 0 and solve, okay? So first you have to take care of that before you try any rational equation problems. Now, step number 1 is the special case. This is a special case. Okay. Now, when you have fraction equals fraction in a problem, and that means there is nothing added or subtracted in the back or in the front. Okay. So for example, we have something like this. Now, we can knock out both fractions by using something. Okay, so here there's no common denominator. You don't have to use that. When you have this kind of equation, what do you do to get rid of two fractions at the same time?
Multiply by 8.
Again, there's no common denominator here. I mean, like you can use it, yes, but you don't have to. There's a lot better way.
Okay.
Multiply in some kind of ways.
Cross multiply.
Cross multiply, yes. Cross multiplication. Okay, which in some high schools, they teach you so-called butterfly multiplication. Have you heard about that? Butterfly multiplication, does it sound familiar? No, not at all? Okay. Now, that's a special case. And now, otherwise, so that means if you don't have fraction equals fraction, now we go back to what she said earlier, multiply LCD of the fractions to each term, and then simplify, okay? And in order to find the LCD, you may have to factor denominators. Okay, well, in some cases, you don't have to. And then you simplify and solve. Now, that is the last step, which is so important. Throw away any values from the previous step that are exactly equal to one of the bad values. Why? What's the reason? They're bad, right? And why are they bad? Zero denominator. Okay, so you always have to compare once you solve with the bad values that you got. Okay? I mean, the reason is simple. They're bad. Okay? They will lead to the undefined fractions, and that's not good. That's not what we want. Okay? So, let's work on the problems. X plus 4 over 2x is equal to x minus 1 over 3. Okay, so now, first thing first, the bad values, or sometimes I call them criminals because they're just bad. Okay, and finding the bad values means like arresting criminals. And how appropriate is that, especially in like these days? But anyways, here, what do we do? Set bottom equal to 0 and solve, okay? So, bad values. Bad values. So what does that mean? 2x is equal to 0 and 3 is equal to 0, right? Okay, now, some of you may notice something funny here, but I will get to that in a minute. Now, from 2x is equal to 0, what's the value of x? 0, right? Do you see that? Now, 3 is equal to 0. So does that mean 3 is the bad value?
No.
No. Okay. This is what? Just false, right? Okay. So what can you deduce? Never set pure denominator or pure number denominator equal to 0 because it will be false. Okay. So only 0 is the bad value. Okay. Not 3 or even negative 3. Okay. So now that's step number 1. Step number 2. Do we have this special case, which means fraction equals fraction? Yes, we do, right? So what can we do? Just cross multiply, right? So that's how you cross multiply, right? Okay, so what do you get? 2x times x minus 1, I mean cross multiply here. Cross multiply. So 2x times x minus 1 is equal to 3 times x plus 4, right? Okay, and now what do we do here? There's only one way, which is what? That, right? So that's how you clear parentheses. Okay, so we have 2x squared minus 2x is equal to 3x plus 12, right? Okay, and now, how do we solve this equation?
Move everything to one side and solve for x.
Okay, now move 2x squared minus 2x to the right or 3x plus 12 to the left?
2x squared minus 2.
So move these two to the right?
No.
I mean, yeah, we can do that, but there's the better way, which is what? Subtract 3x and subtract 12, right? That's better.
Yes, because we don't want a negative 2x squared.
Right, okay. So, subtract 3x and subtract 12. Okay, so what do we get? 2x squared minus 2x, and then we have minus 3x minus 12, right? Equals 0. Okay, so what do we have? 2x squared minus 5x minus 12 equals 0, right? Okay, and now, can we factor this? And if so, when you factor, what are the two factors that you get? Okay, so I have briefly gone over AC method and Mustang method, so I'm not gonna go over them again, but you work out the problem and let me know what are the two factors.
-8 and +3, right?
Okay, so -8 and +3, but that's not the end. Yeah, so those are the two numbers, yes, that matter, but that's not the end.
Then 8 and -3.
Say that again.
8 and -3.
-3? So -8 and 3 are right. That's right. But you have to do something after this.
Make them both equal to 0.
Because you cannot set x minus 8 and x plus 3 this time, right? Because that number is not 1.
Oh, right.
Yeah, okay, so, I mean, this is kind of similar to Mustang method, so I guess, so what is one factor here? Did anybody get it?
Sorry, I'm confused. I'm not going to be any help here.
Okay, well, I mean, like, factoring needs to be the prerequisite for this class, and I cannot go over any more factoring techniques. So again, if you feel comfortable with AC method, feel free to use it. If you feel free, or like if you feel comfortable with the Mustang method, you can use it as well. Okay. So from x minus 8 and x plus 3, if you want to use Mustang method, you have to divide 8 and 3 by 2, and then reduce them, reduce the fractions. So you get 4 here. So x minus 4 is one of the factors. And then for this one, you have to move it to the front of x. So you get 2x plus 3. Okay, or if you use AC method, you'll be using a little bit of different approach, but okay, so again, practice factoring, that's important. I cannot lecture factoring things here. So x is equal to what? 4 and -3/2, right? Okay, so now, do both numbers work, or only one of them works, or none of them works? And how do we know it? We have to do what? Compare with the bad values. Okay, so
They both work.
they both work. Yes, do you see why? Because 0 was the only value that we need to be careful with, but we didn't get any 0, so both numbers are the answers. Okay, so that was A. And then B. Okay, so now part B. X over x minus 5 plus 5 is equal to 5 over x minus 5. Okay, so now here, let's first find the bad values. Okay, so the bad values. So what do you do? Remember, set denominators equal to 0, right? Okay, so what does that mean? X minus 5 equal to 0. And what do you notice for the second denominator? It's the same, right? Okay, so what does that mean? Just 5 is the bad value, right? Okay, and now, step number 2. Can we use cross multiplication here?
No.
No, because we don't have fraction equals fraction, right? So what does that mean? We must have to find the LCD. And then once we find it, we need to multiply to each term and then simplify and solve, okay? So what is the LCD here?
5.
LCD, least common denominator.
X minus 5.
X minus 5, yes. The only, which is the same denominator, right? Yeah, so LCD is X minus 5. Okay, and we multiply this to each fraction. Okay, now when people multiply this X minus 5, they can easily see that it needs to be multiplied to the first and the last fractions. But then what they do is they forget to multiply X minus 5 to this 5 because there's no fraction here. Okay, so if you want, you can make it into a fraction like 5 over 1, that's 1, 5 over 1, and then you can, or you shouldn't forget that you need to multiply X minus 5 to everything, okay? So that means X minus 5 times like 5 over 1, or just 5 if you want, okay? So either remember to multiply X minus 5 to everything, you know, by each term, or just convert everything into a fraction and then multiply it, okay? So now, let's simplify this. X minus 5 times X over X minus 5. How can you simplify that? Does something cancel?
X minus 5.
Right? These two cancel, right? Okay, so we have just X. And now, what's the only way to simplify this? What's the only way to clear parentheses?
It'd be 5x minus 25, correct?
Right, distribute, right? Yes. Okay, 5x minus 25. And then here, x minus 5 is also cancel, so it's equal to 5, right? Okay, so we have 6x minus 25 is equal to 5. And then we add 25 and divide by 6. So 6x is equal to 30. And then divide by 6. So what? X is equal to 5. So that's the answer, right?
And that's the bad value.
Ah, that's the bad value. Okay, don't forget. So now, compare. Okay, that is the bad value. So what does that mean? Whenever you come across any bad values, you have to do what? Cross it out, right? Okay, so what's the answer then?
Undefined?
Right, no solution is the answer, yes. Okay, 5 was the only candidate for the answer, but it was the bad value. So we have to cross it out, so there's nothing left. So no solution is the answer, yes. Okay, so now the last problem of the equation type number 1. 4x plus 3 over x plus 1 plus 2 over x is 1 over x squared plus x. Okay, so now for this problem, again, let's find the bad values. So just as a warning, this problem will be a little bit long. So bad values. So what do we do? Set denominators equal to 0. So we have these three equations. Okay, so now the first equation is fairly easy to solve, right? Which is what? X is equal to -1, right? Okay, and now what about the second equation? Well, there's nothing to solve, so it's just 0, right? And now, how do you solve x squared plus x equals 0? Can we factor this? Yeah, right? Take out what? What do we take out from x squared plus x?
Okay.
X, right? Yeah, GCF is x, right? So what do you get? X times x plus 1 is equal to 0, right? Okay, so what are the values of x? -1 and 0, right? But have we seen -1 and 0 before? Do we already have them? Yeah, right here, right? So what are the bad values? -1 and 0. Okay. So precisely what do you notice? The third denominator is what? The product of the first two, right? Okay. So those are the bad values. And now here, what is the LCD?
X
This one
plus
is kind of
X.
tricky, huh?
X squared plus X.
The third denominator. Does everyone see that? Okay, it's kind of not that straightforward, but here, if you don't see it right away, notice that this problem is in the exact same format as this problem. Okay, do you see why? Because the third denominator is the product of the first two. And for this equation, you can easily see 6 is the LCD, right? Okay, because 6 contains 3 and 2. Same thing right here, okay? So LCD is x squared plus x, or x times x plus 1. Yes. Okay, so now multiply this to each term. So what do you get? It's kind of long. X times x plus 1 times 4x plus 3 over x plus 1. And then plus x times x plus 1 times 2 over x is equal to x times x plus 1 times 1 over x squared plus x. It's long, but it is what it is. Okay, so now let's see if we can simplify things. First product. Can you cancel something here? What can you cancel?
That x plus 1.
X plus 1. Now, what does that mean? You are multiplying x and 4x plus 3, right? Okay, so what do? You distribute to x, right? So what does that mean? You get 4x squared plus 3x, right? Okay, and now simplify the second product.
Take the X out.
Okay, so cancel x, and you are multiplying x plus 1 and 2, right? So what does that mean? You are distributing 2, okay? So you have plus 2x plus 2, right? Okay, and now simplify the last product.
It's just 1, isn't it?
Does everyone see that? Do you see why? So these two look different, but remember, when you factor this, you get x times x plus 1, right? So everything is gone. Okay, so it's equal to 1. Yes. Okay, so you have 4x squared plus 5x plus 2 is equal to 1. And now, how do you solve this?
Combine like terms.
Yeah, which we did. And then,
You have to subtract the 1.
right? So minus 1, minus 1. So 4x squared plus 5x plus 1 is equal to 0. And now, the factorization of this is just a tad easier than the previous problem, or part A, I guess. So here, can you see what the two factors should be?
Is it 4x plus 1 times x plus 1?
X plus 1 times 4x plus 1, yes. Does everyone see that? Okay, so here the sum and the product is what? 5 and 4, right? So 1 and 4, okay, are the two numbers. And then if you want to use Mustang, you divide 1 and 4 by 4, right? So you get 4x plus 1 and then x plus 1, yes. Okay, so what does that mean? From here, x is equal to what? Negative 1/4 and negative 1, right? By setting each factor equal to 0. Now, do both numbers work, or one of them works, or none of them works?
Negative 1/4 works.
Negative 1/4 works. What about negative 1?
No, it's a bad value.
Right, this one is the bad value. So only negative 1/4 is the answer. Yes. Okay, so that's why you always have to compare with your bad values after you get the values of x. Okay? Okay, so again, please practice factoring. Now, any questions on these rational equations? Okay, so now go to the next page, equation type number 2. So this one is kind of interesting but bizarre one. Work rate. Okay, now in work rate, we will see a few word problems. Oh, so you might think, oh wow, now I'm in trouble again. But no, we will follow the exact same format. And that's a really good news. So the formulas that we will use, there are two. So suppose there is a job, okay? Now here, the job does not mean like teacher or like plumber or like maintenance. Like that's not kind of job that I'm talking about. Here, the job means more like a task, okay? Like cleaning or painting, things like that. Now, if a certain job can be done in t units of time, okay, so here there can be many units of time, but we will focus mainly on hours, okay, but it could be like minutes or days and so on. By one person alone, okay, then the rate of work, so here rate means what? The speed, right? Rate of work is given by 1/t. Okay, so what does that mean? You take the so-called reciprocal, okay, of t to get the rate of work by one person. Now, amount of work done. Okay, so now instead of using the rate, we look at the amount of work done when multiple people work together, okay, is given by 1/t. Okay, so now remember that's the rate of work by one person, and you multiply it by so-called together time. Okay, now at this point, the together time may look unclear, and it is unclear, I know, but you'll see why I called it together time once we look at this next problem. Okay, there's a reason. Now, always remember that you have to set x to be the thing you are solving for. Okay, so that's the common goal, no matter what you are solving for. Okay, so now let's look at this next problem. So there are two boys, Ronaldo and Messi. Okay, now if you are a soccer fan, you immediately notice who they are. They're just two most popular, and I guess two nearly like one of the best soccer players in the history. But they're not friends, unfortunately. They are just rivals. Anyways, so what they are doing is not playing soccer, but they are raking leaves in their soccer stadium. And that's just obviously false, right? So don't go to their Instagram and saying, oh, wow, I didn't know you are raking leaves in your stadium. No, it's just false, okay? So don't spread any false news. Anyways, so they're raking leaves, but when each person works alone, Ronaldo can get the job done in 5 hours, and Messi rakes them in 4 hours. Now, when they work together, how long will it take for them to finish the job? Okay, so now it seems like this is really easy problem. People say the answer is 9 hours by simply adding 5 and 4. No, they're not taking break or playing soccer in the meantime. All they do is just like raking leaves. Okay, they're not even like having meals. Okay, so 9 hours doesn't even make sense. Then some people say 4.5, the average of 5 and 4, but again, that doesn't make sense either because, I mean, like how can they need more than 4 or 5 hours if they're working constantly without taking any break? Okay, so that's just false as well. Okay, now here, what are we trying to get? What are we solving for, basically? That, right? That's the unknown. Okay, so what does that mean? That needs to be set it as x. And now, summarize this last question into 2 words. Together time. Do you see that? Okay, it's the together time. Okay, and there we go. Here comes the together time. Okay, so now, to solve this problem, like I said before, we will use this fixed scheme. Okay, so step number 1, we will focus on the alone part. Okay, alone part. Now, when each person works alone, can we get the rate of work by each person? Okay, so now what is the rate of Ronaldo when he works alone?
Five hours.
That's the time, but what's the rate?
1/5.
1/5, yes. Do you see that? Because for the rate, we have to put 1 at the top, right? So 1 over time, so it's 1/5. Okay, and now, what is the rate of work by Messi? 1/4, right? Okay, so that's good. And now, go to the together part. Okay, together part. Now, for the together part, we will not find the rate, but we will instead find the amount of work by each person. Okay, so what is the amount of work by Ronaldo? So what do we do? 1/t. So 1/t for Ronaldo was what? 1/5, right? And now, what is the together time? Is together time equal to 9? No. What's the together time? Like, what did I write on this problem as together
X.
time? X, yeah, right? Yeah. So 1/5 times x, and what's that equal to? 1/5x, right? Okay. And now, what's the amount of work by Messi?
1/4x.
Yeah, 1/4x, right? Due to the same reason. Okay, so we have 1/4 x. Okay, so now, they are working together, right? What is the math symbol for together? Like, what's the algebra symbol, basically, for together?
Add.
Add, yes. Okay, so now, you add these two expressions. And on the other side of equality, we will write a number. Okay, now, what can you think of? Like, maybe think of the simplest number. What do you want
20.
to? Huh?
20.
That's not simple. Like, be really simple.
1. 1.
1, yes. And now, what does 1 represent? What is the percent representation of 1? What's the percent representation of number 1? Convert 1 into percent.
100%.
100%, yes. So 1 represents 100% of job done.
Oh.
Okay, now, does it make sense in terms of the context of this problem? Oh yeah, because when they work together, eventually after some time, they will finish their job, right? Yeah, so set equal to 1, which means 100% of job done. Okay, so what do you notice here? This equation is not that hard, right? It's not hard to solve, but what's the main thing? Getting to this equation is the key. Okay, but again, guess what? We'll use the exact same scheme for the future problems. Now, how do we solve this problem? So earlier, let's see, someone said 20.
Yeah,
So
that's where I thought you were asking that question. Sorry.
Yeah. Oh, that's fine. So 20 is what? The LCD, right? Okay. So we multiply this to each side, right? So 20 times 1/5 x and 20 times 1/4 x. And then remember, we need to multiply 20 to the right-hand side as well. Okay. Now, what is 20 times 1/5 x? This one.
4x.
Yeah, 4x. And then 20 times 1/4 x.
5x.
5x. And then is equal to 20. So we have what? 9x is equal to 20. So by dividing everything by 9, we get 20 over 9, which cannot be reduced, right? Hours. Okay, so now, what does that mean? This is a little over what? Oops. A little over what? 2 hours, right?
2. Yeah.
Yeah, so that makes sense. Okay, and notice that it's not even a whole number. Okay, so that's why you must like work it out like this, and then you'll end up with a fraction. Okay, so we again went over time. So on Monday, we will let's see. So I'll have to look at the pace, and eventually I may have to push back the date of exam 1 to Wednesday, but I'll think about it this afternoon, and then I'll make a decision, and then I'll let everyone know. Yeah, we are kind of behind than what I expected, and that is not looking good, but again, like, it is what it is, and I don't want to go any faster than like what I normally do, like, because I'm already moving fast. So yeah, I'll think about it, but just keep in mind that the exam 1 might take place on Wednesday instead of Tuesday. Okay, and I will post the first extra credit homework in a minute right now, like, again, sometime in this afternoon, and then we'll go from here. Okay, so that's it, and have a good weekend, and I'll see you on Monday at 10.
Thank you, you too.
Thank you.
Thank you.
You're welcome. Have a good weekend.